Okay, thank you, Alex, and thanks so much for inviting me here to the event. It's an event that I've attended a few times. Am I going forward? Am I going backward? There we go. It's an event I've attended a few times, but I haven't been a speaker in the past. So as you just heard, my name is Greg Newby. I'm the Chief Technology Officer of Compute Canada. What the heck is Compute Canada? Why am I here? And what is interesting? Stay tuned. Here it comes. So people standing in the back, there's actually a lot of seats open towards the front of the room if you'd care to sit. I won't be offended if people move around. So, excuse me a sec, let me get this. So I'll tell you a little bit about Compute Canada. We'll talk about the general technology refresh that's ongoing in Canada. And this, I think, is pretty interesting. It'll tie in some of what we're doing with some of the other things that you hear about at the supercomputing event. And we'll focus then on what we're calling the National Data Cyberinfrastructure, which is basically our technology refresh storage element. We'll talk about the particular role of WAS, the DDN product in that environment. And we'll talk a little bit of our forward direction. This is just an abstract I put for saving in the program for posterity. I'm not going to read it to you, and I don't think you need to memorize it. This is kind of a picture of Canada. It's shaded in the lower area because in the lower areas where you have what are called provinces, these are like states, but they're Canadian versions. And then it's sort of gray up to the north because those are what are called territories. And we don't interact as much with the territories. The territories of Canada are very, very sparsely populated, don't have a very big university environment. The lower part of Canada, especially as you get closer to the US northern border, is where you tend to find most of the population, most of the big cities like Toronto, Montreal, Calgary, Edmonton, Vancouver. These are places that you might have heard of. You might even be thinking of moving there, given the... I couldn't not reference current events. What we're doing is we have about 37 member institutions. So those of you that are familiar with Exceed, it's a little like Exceed. It's a little like even some of the statewide programs that exist in the U.S. It's also a little bit like the European model with PRACE and EGI. So we have sort of a different environment, obviously, but we've learned from those examples and done things our own way. What we're doing, so there's 37 member institutions, that's where the stuff is. What we're doing is we're replacing all the stuff, all the clusters. And some of these are pretty decent sized systems, but they're old. They're at the end of life, 5, 6, 7 years old. And so we're replacing everything with a program through an organization called CFI, Canada Foundation for Innovation. And again, I know not everyone's familiar with the U.S. environment, but in the U.S. environment, you have the National Science Foundation, which is under the U.S. Department of Commerce, and NSF funds a lot of the academic research. In Canada, it's similar. Canada Foundation for Innovation is under what's now called ICED, basically the science ministry. So very similar structurally. And what we're doing, as I said, is replacing the older systems with newer systems. And we selected 4 sites for the newer systems initially, and we're going to be selecting a further 5 to 6 sites over the upcoming few months. And this exact table is in a document which just got published today. So if you want to know a little more about what's going on in Compute Canada, go to computecanada.ca, not .com or .org or whatever, computecanada.ca, and you'll see this table and a lot of other description of our technology plan and our status and where we've been and where we're going. What this basically says is we got 4 sites with four systems, and we're at a state of having deployed and installed the first of those systems at University of Victoria. This is basically a cloud system. It's about 250 nodes running OpenStack cloud, and we have a pretty big use case for OpenStack, essentially around virtualization, platform as a service, infrastructure as a service, which is an example of something that we're doing in Canada within the national organization, and in other jurisdictions that's typically a little bit of a separate deal. But Compute Canada serves everything beyond the desktop. And of course, cloud is one of the things that goes beyond the desktop. We have some other systems forthcoming. I'm not going to dwell on those because we're really here to talk about the storage piece. But this is what we call stage 1. It's a stage 1 investment. These are all systems that are going to be online Actually, the first 3 of the systems are going to be online and functional at the start of our allocation year. We do an allocation process. That's April 1st of 2017. So all this stuff is happening. It's pretty good. It's pretty exciting. Just to give you an idea, the challenge, it's called Challenge 2 Stage 1. This investment is about a $75 million capital investment program, Canadian dollars. They're a little smaller than US dollars, but in the same approximate ballpark. So that's a pretty decent sized national level investment in technology. This is a slide, again, this same chart is in this technology briefing that's on computecanada.ca under the publications area. And this is a summary of what we talked about for stage 2. And basically it's more of the same. We're doing another pretty big cluster. We call these general purpose because there are a bunch of different nodes meeting a bunch of different use cases, different needs, different users, different size, like big memory systems, different size nodes, also GPU nodes. They got a big role in our environment. And we're doing a couple of other things that are interesting, and I'll highlight there Elastic Secure Cloud as a national level service. This is very, very interesting, but a little off topic for my talk today, so I'm not going to dwell on it. But it's something that we think is going to be appealing. And we're doing some investments in what you might call technology middleware services. So essentially we're recognizing that, well, Compute Canada is a whole national jurisdiction and you can't, or maybe it's not cost effective, or maybe it's just not ready to go out and buy stuff off the shelf all the time, and we have to develop various things internally. And so that's one of our other initiatives. And that, as you might see in the bottom line there, is I think it's 2/3 the size. Is that right? Yeah, it's $20 million from CFI versus $30 million for stage 1. You double that with the match from the provinces. You add 15% for what they call vendor in kind, which is basically getting good deals on technology, and that's the total. So all told, stage 1, stage 2, 75 plus 50, 125 million Canadian dollars technology investment for about a 2 to 3 year program. Well, we should be well done in 3 years. So that's all stuff that's great. It's happening. It's underway. And what we're going to do is transition to talk just about the storage piece, because here we are at DDN User Group. The storage piece we're now calling National Data Cyberinfrastructure. What's national about it is, before I showed you the map, actually. I didn't point out the 4 sites. But those 4 sites are where the new stuff is going. And so we're rolling out the new stuff at the new sites with new services. And so one of the things we're doing is making use of the network called Canary, which is a Canadian equivalent of the National Research Education Network, and getting all the 4 sites up to 100 gigabit, doing some software-defined networking, some science DMZ, some virtual local area networks, and suddenly we have a national data cyber infrastructure that spans those 4 sites, and we'll add in the other sites later. So we did a series of procurement actions, and that greenish chart was basically a status update on where we're at with the procurement. Basically get a RFP on the street, go and buy it, then it gets delivered, you put it into production. That's what that chart was. The one that we did earliest of all of these actually was launched 11 months ago, and that was what we call a storage RFP. It had multiple elements, and they've all been decided upon. Everything's in varying levels of being deployed, and as you might imagine, we're going to focus on the second one, which is the one that DDN won. But I'll just mention the other 2 because they're actually pretty relevant. The first one especially is storage building blocks. We have this notion in Canada that we should get very good price performance, and also we should avoid vendor lock-in, because we know that can be a problem. Even for the biggest fan of DDN, you're going to be thinking about that as you go through your decision process. So we developed the concept of, well, we weren't the only ones that developed it, but we used the concept of storage building blocks as an element of the hardware, and we'll talk in a moment about software-defined storage. That was won by a company called Scalar, which is a pretty big Canadian value-added reseller, and the gear we're getting from them is basically Dell and Seagate gear. So these are the building blocks, but that could change over time. The whole idea of software-defined storage and storage building blocks is, well, you can put another type of unit in there, and of course the technology will advance, and so the technology we buy in the first group might be different by the time we buy the second group. Backups I don't think I'll talk about now, other than to mention that that's the one thing that's a little bit interesting, just because we're a technology-focused audience, is Compute Canada opted for the LTO product line rather than the enterprise product line within the IBM tape silo. And that's, I just find that to be an interesting point of decision. But that was primarily based on the price performance extrapolating forward as opposed to the snapshot in time. In other words, LTO gets cheaper and the enterprise stuff does not as much. All right, let's talk about this object storage. So, I'm sorry, I think I talked about these enough already. These are the points of software-defined storage and the points of storage building blocks. Storage building blocks talk about software-defined storage is the direction that the world is heading in slowly but surely. The ideal situation for a lot of vendors, of course, is to lock in, products, software, support, product line advancement and so forth, so you don't have as many choices about exit strategies. This does still sometimes happen, and even within the software-defined storage realm, you do make decisions that are going to kind of lock you into that environment. So for example, we're looking at a lot at Lustre these days for persistent storage over the wide area network. Okay, well, you might be doing software-defined storage with Lustre, but you're still making a choice of Lustre that's going to shape your technology choices for years to come. So there's no such thing, in my view, as sort of a pure software-defined storage, entirely agnostic, absolutely portable decision. But we're heading in that direction to the extent it makes sense. And again, avoid vendor lock-in, get very good price capacity, total cost of ownership type of consideration. And I'm talking total cost of ownership, so we do bundle in, operational costs of various types. And also riding the technology curve, trying to be as early as we're comfortable with in the technology curve. And of course, the comfort level isn't a single thing. It depends on what you're doing. But we don't want to be in a situation where we can't adopt new technology because we're locked into some older technology. Okay, so I think that's enough said about these two principles. And this isn't like a federal policy or something. No one's forcing us to do this. We're not saying we shall never buy a vendor appliance. In fact, we are buying appliances and various vendor-focused solutions. But these are sort of principles that we're using to guide us. Let's talk about object storage. So as I didn't stop because we're going into that detail now. On the 2 slides ago when I talked about the winners of the storage RFP, the one in the middle was object storage. This is something that we decided to procure based on user demand. And it's not your typical HPC user demand, as you can imagine, although there are some pretty big HPC users that are interested in this. It really comes more from the same types of folks that are interested in, and are using our OpenStack cloud environment. They're essentially saying, look, we're developing various types of software platforms, and we want to make use of sort of modern APIs, so S3, is the one that keeps coming up, for managing our storage. And we have desire to do sharing of storage in various ways. So they want to have maybe a little bit better than a POSIX access control list level of control over data, including publishing externally, which of course you don't really publish externally from your Lustre file system typically. So there's a couple of use cases that object storage seems to do pretty well. One of the main ones that motivated us was replicas. So what we have, and I'm giving this as a story in case it's useful in your environment, what we have are a number of users that take data replication, what we call resiliency and durability in the storage area. But they take that very seriously. They want to make sure there are multiple copies in case the bomb drops on Vancouver or whatever. They want to make sure there's a separate case. And these are driven by some of our very biggest users in Canada that are dealing with observational data. So it's not so much the HPC use case where, okay, I lost a run, I recompute. Even if it's a big deal, I can recompute. That doesn't apply. It's observational data. If you lose the observational data, and this is astronomy, we're also doing, well, genomics are maybe you can redo it. But with astronomy, it comes down to the radio telescopes or the visible light telescopes. They capture it in the Canadian Astronomy Data Center, put it on our storage system, and if we lose it, it's just gone. It's as though that observation didn't occur. So in this, and I'll drill down on this particular user group, CADC, which is run by another government organization, by the way. So it's not like a user, academic type of thing. It's an actual government project run by Natural Resources Canada. So Canadian Astronomical Data Center is doing data replication for the reasons I just described. No problem. It's great. We love them. We get along. We work really well together. They know they can rely on us. Everything's cool. But they're doing it in a way that gives us heartburn. And what I mean by this is that they're sort of brute forcing data replication across multiple systems without really working with us at a detailed technical level to make it all very smooth and functional and stuff like that. So to give you an example of one of the stories we heard, I think a few people in the audience have heard this. They come to us and they say, hey, in the last year we've had 200,000 errors on your data storage. We're doing data replication. You have 200,000 errors. What's up with that? What, and what is the 200,000 errors? It turns out they have like a wget script that runs in a cron job every once in a while and tries to ping all of the files that they think are out there. And if a network link is down between here and there, they treat it as their data being, whatever, temporarily or whatever lost. And we say, well, it's not, in our view, that's not exactly a case of data loss or something like that. But they're counting what they can count, and they're nice about it and so forth. But they're counting what they can count against their system, which they've designed, and they've designed it in a way which, in this particular example, is not making best use of shared resources. So what does WAS do? Well, WAS does object storage, in general, but WAS in particular gives you a number of different good opportunities for data replication. And so that was a key feature that helped me to convince the upper level in Compute Canada to say object storage might not be what our HPC users are doing, but this particular feature, this data replication, and there's other reasons that were on the previous slide, this particular data replication feature was really a driving factor. So this is a picture, and if you know WAS, you'll recognize a little bit of this, but it divides out to our 4 sites. This is basically saying you got erasure coding over the wide area network, you have on-site replication, you have two-way replication, and you have various levels of striping so that you can accommodate data efficiencies at like a 1.5 to 1.8 instead of a 2x replication. So, and again, if you're familiar with WAS, I'm not here to tell the WAS story, but if you're familiar with WAS and you know some of those languages. And you see that what we're doing is we're basically drawing a couple of different boundaries around our WAS zones so that for a given user, so CADC, for example, they can say, oh yeah, let's take our couple petabytes and we're going to put it in a two-way replica environment, and we say that's great, and due to the efficiencies we get out of WAS, A, it's not going to give us heartburn, because you're not going to generate these 200,000 errors because everything's going to work. And B, more importantly, we're not going to have you pushing out copies kind of when you want to. We're going to handle the replication mechanism under the covers, or WAS is, and it'll be a smoother, more supportable, more scalable process. What we're doing with WAS, this is the science DMZ concept. What we're doing with WAS is we're putting out these 4 sites on the building blocks. We're going to add additional sites in the future, and that's a fairly friendly process within the zoning system that WAS provides. And we'll have a layer of different access models. So one of the things that's actually, let me go back to here. One of the things that's a little challenging with WAS is all the features are in there, and we bought it on that basis, but not all the features are fully available depending on the choices you make of other features. So one particular thing is that S3, which is a mechanism we're going to use for object storage. S3 has a namespace, and that namespace is not the same as the namespace for your GPFS or your Lustre connectors into the same back-end object store that the picture we have here, and that's basically kind of inconvenient. It would be nice if the users had universal access to their data and the S3 and the GPFS were just an access method. On the S3, there's data replication, another topic. On the S3, there's data replication, so we can do two-way, n-way, whatever. But to get the S3 object out, you have to go to the connector that you put it in at. And this also is an inconvenience where CADC is going to say, well, is that available or not? Because if the connector drops off the face of the planet, it doesn't matter that the data are there someplace if I don't have access. So those are 2 examples of things where the WAS feature set is fantastic, but the full set of interoperability across that feature set is still something we're working with DDN to get things on the time frame and so forth. So I think I'm at the end of my time here. The early experience so far with WAS has been very good. We're getting it into production over a period of a few months. Full production isn't scheduled for April 1st. And as I said, the technology deployment plan is online, and you're encouraged to take a look at the exciting things we're doing in Canada. So I think that's all my time. Unfortunately, I'm not able to stay afterwards. I have another part of the program I need to go to, but we're trying to get the slides in, and my email contact is very easy. Be happy to talk with anybody about this anytime. So thanks again to DDN for having me today.